So today we are going to see a very important topic in C and C++ and other languages, whether they use or utilize it directly or not indirectly. So we are going to see pointers, and before we go ahead, let me tell you about the outline today. We'll talk about computer memory structure because essentially pointers deal with memory only, because memory addressing concept we'll see. Then introduction to pointer manipulation, and then summarize. So computer memory revisited. Computer store memory or store data in memory slots. Just like your house and my house, we have addresses. In the similar fashion, computer memory has addresses. Each slot where the data is to be stored, is to be fetched, is to be read, has a unique address. Thus, this slot has a unique address, and variables store their values like this. For example, if you have an address, the content is say I equal to 37. Maybe in another address or contiguous address, you can have say j equal to 46. In some other address, you can have k equal to 58. You can also have various addresses where there is no content, means those storage of data is not there. And you can also have a pointer. What this pointer is means at every address you can even have a data or the pointer. So pointer is actually data only. The only difference with pointer is a variable also. So pointer and other variable or other data type or other value is that pointer only store the address. Pointer cannot store a value. It will never store a value. It will store only these addresses. Only these addresses, never any other thing, like all these in the second column, or this column, this column, this column, this column. Not a single value can be stored in a pointer. Pointer can only store a address. So altering the value of a variable is required, is indeed changing the content of the memory. When you are trying to convert it or modify it, you are actually changing the content of the memory. For example, if you are saying I equal to 40, what was in the previous case, what I was holding? I held 37. But now I will be 40 because I was given the value of 40. In the similar manner, we are providing z. This is a character z, and an ASCII value will be taken out, or it will be given to A2. So what is going on? This one 1006. Previously it was A2 equal to C. Means the value in the array, this is actually array, value of array. So we have modified or replaced C with Z. We are actually playing with the memory. But what about this addressing concept? Because pointers store only the address of another entity. Any entity, the other entity can be anything, but the pointer is only going to store the addresses. So it refers to a memory location, because address only refers to a memory location. Address only refers to the memory location. If this concept is clear, means pointer can only store, pointer will only store address. Everything will be clear if you can get these particular line, because this is very important. This is actually the crux of pointer. The pointer only contains the address of another entity. For example, this is int I equal to 5, so I is a simple variable and 5 is assigned to I, or I is initialized to 5. But we are initializing a pointer. So how we are going to initialize? We say ptr. Don't worry about the name. This can be anything. This can be your name also. This can be anything which a valid variable name. You can have it as a pointer variable. But how the system is going to know, how the programmer or compiler is going to know that this is a pointer? We place a star here, or we call it asterisk. Asterisk we call it, or in normal language, in name language, it is star. So if a variable is preceded by a star, we declare a pointer variable. Now this is a pointer variable. But how this pointer variable is going to get the address? Because I told you pointer can only store the address. So we have ampersand operator. If you place an ampersand between any value, if it is preceded by ampersand, then this will give this execution will give the address where I resides in the memory, where I is placed in the memory. And if you want to refer to the referee of pointer, what you are going to do, you just type or you just print star PTR, because star PTR or asterisk PTR will give the value of the pointer which this is pointing. Pointer is pointing to some value, so star pointer will dereference it and will give you the value which this PTR is pointing to. A PTR is holding an address, the value on this address will be provided to you. That is why it is %d. Otherwise, it will not be %d, it will be a hexadecimal number, because pointer will be an address, memory address, it will not be %d. So why do we need pointer? This is an important question. Why? You may argue that simply because C provides it, because there is no other option to handle memory, or to provide memory, or to allocate memory. Then simply because it is there, it is used in some circumstances in C. What are the circumstances? These are the circumstances because scanf uses it. It is already there. You are placing an ampersand I in front of this I, in just ampersand is giving you the address. So this %d will actually is saying that I am going to scan a value I, but I am going to place it. I is an integer variable, but I am going to place I at some address. This is how scanf works. So what actually pointer is? We have talked about the pointer a lot. I hope you understood what pointer is, but we still need to understand what actually pointer is, because this will be very confusing as if you don't understand it right now. Pointer is a variable storing an address. Pointer is a variable storing an address, and pointer is not storing the actual value of I. Please understand, pointer is not storing the actual value of I, because I has a value of 5. And the address of I will go to the pointer. I, wherever I is, the address of I will be the value of this PTR. So if I is 5, I told you that the star PTR will tell compiler that this PTR is nothing but this is now a pointer. It will hold only the address of some value. And by doing this, we have assigned an address of I to PTR. And if you want to just print I, simple printing is like this. If you want to print I again, then you can just dereference it, means you use star PTR. This will actually print the value which this PTR point. And if you want to print PTR, it will give the address value. It will not give the actual value, it will give you an address value. So the output will be this I will be nothing, only 5. Again this dereferencing has occurred, so we'll have a value again 5, because PTR is pointing, PTR has an address which is pointing to 5, and star PTR means it will give you a value at that address. And now this will give you an address EFF5E0. This is an hexadecimal number, memory address, you can say, a memory slot address, right? So value of PTR will be address of I in memory. Now this ampersand, we have used it, but what this is exactly? This is the address of operator. We call it as a address of operator because it gives you the address of an entity. It takes out if you precede j with ampersand, if you precede ampersand with any value, not even j, not only j, just precede it by ampersand, it will give you the address of, and this PTR will hold now the address of j. See, there is a slight change. PTR is now having an address, and this 1001, which is what is the address which this PTR is pointing. So PTR is having a value of 1001, which is actually the address of j. Now we want to dereference it. This is a dereference operator. What dereferencing is? Just a star in front of a value or a pointer. So star PTR, this refers to the content of the referee. Means you are not talking about just hide this for a while. PTR is what? Is address. If you put a star here, then it will be a value. This PTR is pointing to some value, or PTR is containing some address which is pointing to some value. This 99 will be actually assigned to the PTR or the address for which is contained in PTR. So PTR is having 1001. So this address which is actually 1001 will be assigned values of 99, not 33, or it will be replaced by 99. For example, why these are important? Just imagine a function. This is a function. This g function is calling f function. So this function will be calling this function. So we are passing a value I equal to 3 in this function. So I will go here, 3 will go here, and j equal to 5. But when we pass 3, this j will be overpowered, or you can say will be assigned j equal to 5. So what will be the value here? When you print fi, if you want to print I, you will get a value of what? 5, right? This is not right. This is incorrect. I'll tell you how. I'll tell you why. The normal imagination, normal thought is, when I am passing 3, it will go to this function, and when 5 is assigned to j, 3 will be replaced by 5, and now this will be printed as 5, no problem. But no, this is not the case. This is not what actually happens. If you really want 5 here, then what you have to do is, when you have I equal to 3, or when you really want the address of 3, you pass ampersand I, means you are passing the reference of 3, you are passing the address of 3. Now when you pass the address, this star PTR, this is actually kept here or chained here to gain or to get the address which is provided by ampersand I. This PTR will have address, star PTR will actually contain an address, and this is a dereferencing. So if you assign 5 to this star PTR, then now the value which this PTR or a pointer is having, the address which is having, and the value which is stored at this address is actually 3. So it will be replaced by 5. Now the result will be I will be 3 here, as assume that it should be 5. It is not the case, but here when we use this as we pass the reference and we accepted it with a pointer, the value is actually changed, and we call it as passing by reference. Let us have a simple illustration. I equal to 5, j equal to 10. So the name of variable is I. It is an integer. It is an integer variable. The value is 5. Simple. Same with j. It is having a value of 10. Now we have int star PTR. So PTR is what? This is a integer pointer variable, not a variable, just not a variable. It is an integer pointer variable, and the value is some EFF something. It will be a hexadecimal number, but the type is in star. This is the type. Actually, this is, you can understand something like this: int star, and PTR is kept alone. This is the type. Int star. Basically, if you write int, it will be an integer. If you write int star, it will be a pointer. Now coming to this int pointer PTR. What is this? This is address of an address of a pointer. Means a pointer contains the address, but you have another pointer which contains the address of the previous pointer. Let me tell you. This PPTR is nothing but an address of an address. Means this integer pointer, this is an integer pointer variable. Again, the value will be something like this, and this is a double indirection. 1 star means it keeps the value of an address. Do 2 star, so it will keep an address which is actually the previous address. Then PTR is equal to %i. This stores address of I to pointer, because I will this ampersand will give you the address. So PTR will contain what? This is actually star PTR is store. This will be simple integer because we have dereferenced it. Then PPTR is equal to % of PTR. This address, this is storing the address of PTR to PPTR. It is storing address of, because this PTR is storing what? This is storing the address of I. Now PTR is also a variable. It will also have a variable. Means it will also have some address. So this address of this PTR will be kept in PPTR. But since this is address of an address, what is this? This is actually ampersand of I. If you understand like this, so you are actually having two ampersands. So you are having two addresses, or you are indirecting it twice. And what about this star PTR equal to 3? So 3, this is star PTR is nothing but this is integer only. This is a dereference of PTR. So it will contain a value of 3. This PTR or a pointer variable, which is actually the address. So this address is pointing, or this address is keeping a value 3 now. So this will be printed as 3. Now star PPTR, what it is going to give? This is going to dereference of PPTR. So actually your I will contain this value only. The value will be 7. Nothing. There is no complication. Only that we are talking about I. It has some address that is kept in PTR. Now PTR has some address. It is kept in PPTR. So when PPTR is dereferenced twice, it will go back to your I only. So it will be 7. PTR is equal to %j. Now we have an %j. So j will be what? J is nothing but 10. So address of j will be given to PTR, and one star of star PPTR will have a value of 9. So what we are going to have is this dereferencing. We can provide a value of 9 because this is actually dereferencing. So it is nothing but a simple variable, not a pointer. And once you provide star PPTR, because actually 9 value has come, this PPTR star, this only one star will have ampersand of I. This will be 5. So it will be value of PTR. So address of I will be given. And what about this star PTR? This will be having value of -2. So now it will actually contain this star PTR, or this is containing, actually I will be provided the value of -2. This is what this whole illustration is all about. And pointer arithmetic, pointer can be added. Values can be added to pointer. What is PTR? PTR is nothing but an address. If you add 1, what will happen? It is a memory address. It will be in hexadecimal. So what you are going to get of adding 1? This is nothing but you are going to a next location. If PTR -1 is there, then you are going to a previous location. And what about PTR into 2 and PTR by 2? These are not valid. These are not valid. Only plus and minuses are valid. Pointer arithmetic and array. Let us see what is going on. This is float. This is an array. So it has 4 values: A0, A1, A2, A3. These are all floats. And these are float array element. And what are the values? Right now we don't have a value. But PTR, we have declared it as of float star. So this will be a pointer which will be having an address of a value which will be a float. A value which is a float, this pointer will hold the value, the address of that value. Now what about this ptr is equal to ampersand of a2? This is going to give you, because a2 is what? This. So ampersand of a2 is what? The address of a2, means address of this array location, and this will be given to ptr. So this will be a float star type, because this is actually a float star, and it is actually float pointer variable, and this contains the address of a2. Now what about star ptr is equal to 3.14? This is dereferencing, so it is actually nothing but a2 only. So a2 will be inside a value of 3.14. So now this has a value of 3.14, which we have replaced. What about ptr plus plus? Because ptr is holding the address of a2. So once you add 1, you will go to a3. Nothing, just plus 1 means you are going to go to a3. What about this ptr equal to 9? This will be now you have gone to a next level, next value, and now you are assigning 9 to plus this star ptr. So this will, because we have already come to a next location and we are providing a value of 9. So what was the next location of a2? It was a3, and we have assigned a 9 to a3. So now a3 will have a value of 9. What about ptr is equal to ptr minus 3? Now you are already here. So just you are trying to go to this position, minus 1, minus 2, minus 3, and now you are assigning value of 6. So now what will be the change? This change 6.0. This value will be 6.0. Now you are trying ptr is equal to ptr plus 2. That is, you are trying to add 2 values, means incrementing to 2 memory locations, and you are putting it 7. So now what will be the value? Actually you are providing a value of 7. So now this will be replaced to 7, right? So actually you are replacing this, which was previously 3.14, will be now 7. And if you have this was already there for a4, and the type of a is actually float star. This a is nothing but float star. So this a2 is nothing but star of a plus 2, which is actually ptr is equal to ampersand of a2. So address of a2 is nothing but ptr. It holds the value of address only. So ptr is nothing but you replace a2 by star a plus 2. So this will be equal to this. You cancel it down. So ptr will be actually a plus 2. Actually, how it happened, this will be confusing, because this a is nothing but it is already a memory address constant. Array name is the address of the first value. It keeps the first value of keeps the memory address of the first value. So this ptr is a pointer variable, and hope you understood all this. And what if a is a double array? We have seen that it was integer, it was quite easy. But what about double? Double may occupy more memory slots. Integer may have 2, integer may have 4, double may have 8. So if you have a double pointer, which is actually v, when you point ptr plus 1, it will go to, say, if you assume it to be 8 or 4, it will go to this location. And the arithmetic operator plus and minus auto adjust the address offset. It will be true for this only. So according to this type of the pointer, 100, 1000, plus size of double, if you assume it to be 4, it will be 1004. So once you just add plus 1 to some pointer, it will go to 1004. So there are certain advice and precaution you need to take care, because pros are efficiency and convenience. No doubt, pointer helps you a lot. And the cons are error prone, difficult to debug, and some standards like MISRA and JFK, they strongly recommend that you shouldn't use this pointer, which is actually impossible. So let us summarize. A pointer stores the address of another entity. The address of operator, this ampersand, gets the address of an entity, and dereferencing operator star or asterisk makes a reference to the referee of a pointer. So pointer and an array and pointer arithmetic we have seen. Thank you so much. Take care of yourself.